Okay, so if you could, yeah, let me know where you're coming from, what kind of tools you're using right now, and what you're hoping to learn. That would be great. And we can kick off very shortly. So today's stream is about processing data faster with any tool. And to be able to process data faster with any tool, what we need to learn is basically some of the principles of kind of what makes data faster, processing faster, and what makes it slower. And a lot of these principles we are going to be taking from computer science, but I'm going to take computer science principles and give it a little bit more of a kind of data twist to it. So this is kind of computer science 101, but from the viewpoint of a data analyst, basically people who work with tables. So if you're working with Excel, you're working with R, all that kind of thing, then this should hopefully be useful to you. Okay. Okay, just gonna shrink my face down a little bit here. Okay, so on the left here, we have a bunch of things that make tools work faster. So again, as mentioned, these are kind of computer science type principles, but effectively taking a bit of a data twist to it. So when we get down to things like structures, which seems to be something that people are quite interested in, we're not going to be talking about arrays and lists and that sort of thing, which you'd normally talk about in computer science. We're talking about different types of structures like rows versus columns versus graphs and different things like that. So, and a few other bits. So here's the different points we're going to be covering, and let's kick off, get going. And again, yeah, when we go through this, just let me know if you have any questions, anything, if it makes sense, give a thumbs up. If something's not clear, please let me know as well, so we can go through and address that. Okay, so first of all, I've put together this kind of little map here, which is looking at various different tools and, how fast they are, how slow they are, and how easy they are versus how hard they are. Now, this is not all the kind of different attributes or features of a tool. So, there's different reasons why you might want to use different tools other than the fact that they're slow or fast or easy or hard to use, such as the particular functionality of the tool. But, that's probably something that we'll go over another time. The other thing that you have to kind of take into consideration here is, what are we talking about when we say slow or fast? So we're talking about slow or fast for a computer to process, right? Now, the difficulty of a particular tool, whether it's easy or hard, hang on, I think my face is blocking that. Okay, so whether it's easy or hard is partially determines how fast it is for the user to implement, right? So if something is very easy, then it can be very quick for the user to implement. And that's also a consideration to think about as well. Right. So now again, let me just pop back here. We've got all these different kind of principles: reduced travel, data types, memory management, reduced calculations, parallel processing, and structures. Now, okay, so we've got different languages, and we've got programming languages like R and Python. And if you've been following my channel for a while, we would have talked a lot about these. And we talked about how R and Python are going to be like much faster than something like Excel. But why is that? That's a lot to do with the kind of structures of it. Now, you've got other languages such as Java and C++. And why are these things faster than something like R or Python? Well, there's a number of reasons. It's usually to do with data types, memory management, and a lot of really kind of low level stuff. which takes quite a bit of time to implement. But if speed is really, really important, then, perhaps you want to implement your algorithms in one of these type of languages instead. But generally speaking, for the data analyst, these aren't very productive tools because they don't really support the kind of data structures that we tend to work with, which is basically tables, data frames, that sort of thing, which makes it much, much easier for people to work with. That's why people are familiar with things like Excel and SQL, and R and Python basically have data frames, which all have a very, very kind of similar structure. Okay. Also on this list here, we have some of the data visualization tools. Now, I would say a lot of people, because a lot of people were familiar with Excel, a lot of people may or may not be familiar with these kind of data visualization tools as well. I think that these are actually easier than Excel because you don't really even need any formulas or anything to make them work. These work faster because of the data structures that they contain. We're going to cover that off a bit more too. We've got things like Microsoft Azure and AWS. Now, these are kind of interesting. Now I've put them around about here on this little graph here because they're sort of faster than things like Java and C++, but they're faster in different types of ways. So the way to kind of think about these kind of things here, because C++ and Java, they can do their processing very, very quickly, right? If you write the code well, you can process things very quickly. The analogy I like to use with this is, let's say you have a restaurant, and you want to serve customers, say, all around the world, right? Would you want to have one really, really, really fast waiter to serve all your customers? Or would you want to have lots and lots of waiters distributed all around the world in different restaurants who are close to your customers so that they can actually serve them? Well, I think that's fairly obvious there. That's kind of what these cloud-based services give you, right? So this is the big thing here. It's distributed computing. It's basically copies of your processing in different availability zones all around the world. And so when you have lots of people, or where you can do parallel processing, or you have multiple people requesting your services, then this is where these kind of things really speed things up a lot. And down the bottom here, I have VBA and stuff as well. Now, here's the thing with VBA, and I have a kind of I'm going to be putting out another video about this as well. VBA is a scripting language similar to R or Python, and well, it kind of works with Excel, right? But it doesn't have a model that works directly with data very well. It has a model that kind of works with Excel. Now, I actually used to teach VBA like a few years ago, and now I would generally not recommend it, just because there's kind of better solutions for most of the kind of things that you want to do with VBA. But again, that's something I'm looking to cover off in another video. Okay, so let's talk about reducing travel. Okay, so inside your computer, you've got all these bits and pieces, right? So you've got a CPU, okay, and these things work very, very fast. Then you've got your RAM or memory, which is not as fast as a CPU, but it's got more storage, right? So up the top here, we have storage capacity, and down the bottom here, we have speed. So as you can see, as you kind of go up, this is a hard drive. So these three components here are all the bits and pieces inside your computer. So this is kind of like the permanent storage for your data. As soon as you want to process it, it gets loaded into RAM, and then it gets passed in and out of the CPU to be able to process it, right? Once you start going into things like distributed computing, different things like that, or just other computers on your network, right? You're going to be able to get more storage, more computers, and everything like that to be able to run things in parallel. But once you move out to a network, things are going to be significantly slower to access. So, let's say, I don't know, for argument's sake, you're working at your desk. This is like the stuff on your desk. This is like this stuff on your side table next to your desk. This is like the filing cabinet, on the other side of the room that you have to go access files out of. This is like having to, walk to the office next door to be able to get your data. And then once you sort of going out to the internet, I mean, you almost have like unlimited capacity and storage, but the connections are much, much slower. So that is kind of those different things there. And so one of the objectives of making things faster is that you want as much stuff to be going on between the CPU and the memory as possible, right? So as soon as you have to start swapping stuff out to disk or to the network, that's when things start getting really, really slow. So how does this actually relate to any of the different tools that you're using? Usually the first time when you load the data up, the data is it's going to load from the hard disk onto memory, right? And a lot of times when people are setting up their processes, they and they want to rerun their processes, they start reading their data off disk. And they do that again and again and again. And that's one of the things that can massively slow down your processing. So say you're in R or something like that, instead of using read.csv and rerunning read.csv every time you want to rerun your script, have a staging process so that your data loads from your files off the disk into memory, and then don't change that. Don't change that data set. So you have a original data set of freshly loaded data in memory, which you can continually access and refine the process, because a lot of time when you're exploring your data, you're going to want to change the way that it's processed. So if you have an object or variable or something like that that happens just after the load, and then you don't change that at all, then it's going to save you a lot of time. Here's the other thing as well. Sometimes people write back to disk and back off disk as a kind of staging area. Again, that's going to be really, really slow. If you can, just keep it in memory, and that's going to be a lot faster. Now, when we're coming to things like Excel, one of the things that I've seen quite often actually is that people sometimes they load Excel files off the network, right? So there's kind of this yellow cable representation over here. And that can be really, really slow for kind of large files. Now, here's the other thing with Excel. By default, and this is kind of the pro as well as a con of Excel, is that Excel automatically recalculates every time you touch anything. And this is why that it can be quite heavy on the CPU sometimes, even though it's not necessarily doing as much, it's repeating a lot, right? So when you're going in and out of, when you're accessing the CPU over and again and again, that's going to take a lot of processing. Now, Excel also has an autosave feature. I think the default of it is like every 10 minutes. Now, sometimes if the file is big enough and your network is slow enough, then it can be taking almost 10 minutes sometimes just to load your data from the network. Now, and if you have very heavy calculations in Excel as well, you can find sometimes that, it could take more than 10 minutes just to do the calculations. Now, if it's auto-saving every 10 minutes, then basically what happens is Excel by default as well, automatically recalculates the entire sheet, right? Actually, it does more than that. Excel recalculates not just the sheet that you have open. Excel actually recalculates every workbook that you actually have open at the same time within the same instance of Excel, right? So that's the other thing that can make Excel really, really slow. So, a few things that you can, simple fixes are just make sure that you don't have more than one copy of Excel open, or if you do, open it in multiple instances. And the other thing is that you can turn off auto calcs and auto save, right? Or adjust the auto save so that it's not taking so long. And this can literally convert your spreadsheets, which basically crash your computer, to spreadsheets that will actually work, right? The other thing that you can do as well is, if you can, maybe take a copy of the file off the network, put on a local drive, right? Do your work and then put it back to the network after, right? Instead of it constantly auto-saving to the network, because yeah, that's just slow. Okay. So, now, just one other thing I wanted to talk about on this slide here is, okay, the cloud, right? So we're talking about how, often I've talked about the cloud a bit, and how it can make things faster, but it's all the way on this side of things here where the data transfer of it is really, really slow, right? So how can we make it go fast? It's like, well, the cloud is actually kind of made up of lots of computers and stuff as well. So if you're using a cloud-based service to do your calculations, what you want to do is you effectively want to do all the processing in the cloud, so that it's not transferring down to your computer to do the processing. Do it all in the cloud, aggregate the data, shrink it down, and then send back just the sort of summarized results, right? And that's something that you want to take into consideration as well. All right. Okay, let's talk a little bit about data types. Right. So again, this is something that you kind of learn in computer science. So we've got different data types. Now, we just talked about how much storage capacity different things have, like the CPU and memory and different things like that. Now, the kind of base unit that everything's measured in is bits, right? So, and these are different data types. So Booleans are basically trues or false. Characters are basically letters, but normally we don't just have single characters, we have words or strings, which are made up of multiple characters. So, you have to make sure that you allocate enough memory for these kind of things. We have integers, which are basically whole numbers, and we have doubles, which are numbers with decimal places, right? Now, there is much more data types than this, but anyway, this is just a few of them to give you an idea here. Now, why is this important? Why do you actually care about, any of this? Well, when you start going into bigger data sets, or when things start becoming slow, by being explicit about the data types that you actually use, you can basically process a lot more, right? So a Boolean is a single bit, whereas an integer is 32 bits, right? Which means if you can use the data type, if you know in advance, like what the data type is, then, you could be processing 32 times more data with the same amount of memory, right? Now, another way to think about it is, say you have, like a big drawer or something like that with one sock in it or something like that. So it's not very efficient use of memory or storage if you only put like a little bit of information into it, but you're allocating a lot of memory to it, right? So this is where these kind of concepts start to kind of come in handy. And these days, when you're using kind of high-level tools like Excel and even R, you generally don't need to think about these things quite so much, because a lot of this is basically taken care of for you. But again, this is one of the reasons why some of these things also run slow, because if you don't need to think about what kind of data that you need to allocate memory for, then basically it assumes that you have to have the largest storage size available, right? So, if you don't know whether you're going to, get a cupboard to put in one pair of socks or, say, a bicycle or something like that, then, you have to be able to allocate for the bigger item, right? And this is one of the things that makes things very kind of inefficient, right? So related to data types is, again, kind of, it's going to go into memory management, but let's just take a look at this for a second here. I've got this slide, and what this is here is this is actually Power Query in Excel. So a lot of people don't necessarily know this exists. If you follow my channel, you should know that Power Query is there, and this kind of gives you a layout which looks a lot more like something that you'd see maybe in a database or something like that, right? So in R, you've got your data frames, and the thing I want to point out here is that the columns have different types, right? So we've got 1.2 over here, so this is a double, right? We've got all these ABC columns over here, which means that these all these columns are text, and I've just clicked the drop down menu here so that you can see all of the different data types that are available. So I mean, from an analyst perspective, sometimes you're just thinking of the data types in terms of, I know, this column's text, and I know this other column is a date, so that's the data type I'm going to use, right? That makes sense. But there was kind of another perspective from it as well. And once you start getting into things like machine learning and different things like that, then you're going to come up to concepts like encoding, right? Because for the computer to be able to process data effectively, the computers just read ones and zeros and stuff anyway. So even these text fields, which are categorical, which most of these are, we have a name field here, which, maybe for purpose of machine learning, you just strip that column off altogether. But these categorical fields, maybe what you actually want to do is convert that into a number, because maybe you only have 10 categories. So, maybe you're converting that from a number from 1 to 10, right? Or, sometimes depending on the algorithm that you're using, maybe you want to split that into 10 columns and code them all as ones and zeros, right? Or something like that, right? So different things to keep in mind there. Okay, so now we're going into memory management. So memory management is basically saying that, okay, well, we only have limited memory, right? We only have limited memory on a CPU. So what we need to do is, once we've finished using that memory for our particular task, we're going to clear it out. We're going to take those things and deallocate the space so that we don't, so that the space can be used for other things, right? Because again, if your processes are taking up lots and lots of memory, and they're taking up more memory than you have available, then what happens is that your hard disk or other storage device needs to be effectively used as memory, as a temporary memory storage, and the reading in and out of data takes a massively long amount of time and can make your processes run exponentially slower, right? So in terms of memory management, this is where languages like C and like kind of really low level languages like that come in. So, perhaps from Excel and R, you're maybe not necessarily thinking about these things so much, but say from a more practical standpoint, a few things you can do is, for instance, pre-aggregate your data, right? You don't always need to load in all of the data to be able to find the answers that you want. And pre-processing your data by aggregating it can again make your processes run thousands of times faster. So that's kind of not really strictly memory management from a computer science perspective, but I think that's kind of what's useful to know for data analysts. And that kind of ties into the next point as well, which is reduce calculations, right? So, here we have a picture of a maze, and it could potentially take a long time to a lot of processes to kind of go through the middle of this. So a lot of times you want to kind of be thinking about, okay, well, do I really need to run all these processes? Especially if you're getting into a bit more programming, you're getting to loops and different things like that. Then the process is being run over and over and over and over again. And certain functions that get called are more processor heavy than others, because they, again, and this goes back to things like data types and different things like that. If you don't need to specify your data types, then the computer has to run an extra set of processes effectively to figure out what your data types are, and run your processes based on that. So there's a number of cycles, or computer cycles lost to just figuring out what type of data that you have. Now, again, because computers are so fast these days, I think we kind of take for granted that we kind of don't really need to do these things. But again, it's just something to keep in mind when you're starting to kind of hit the wall with certain things. Again, if we're taking this back to Excel, one of the challenges with Excel is that in order to use formulas against a number of different rows, what we typically do is fill that formula down. Now, in other languages like R, that's, you're calling the function once, right? And it's going to work on every single row or every element in the vector, right? Now, with something like Excel, you fill the formula down and you actually have lots of copies of that formula. So say you have 1,000 rows, then that formula gets copied 1,000 times and then needs to be called 1,000 times. So this is why Excel doesn't scale particularly well, at least not in the spreadsheet kind of mode, right? Which is what most people use, right? And this is one of the key reasons why I like to teach Power Query for Excel, because Power Query does this much more efficiently. It doesn't need to copy formulas to make things go faster. So, again, this is a massive speed improvement. If you're doing VLOOKUPs, which is probably the number one thing that kind of slows down spreadsheets, is if you do a Power Query merge, right? Or, like do a merge in R or something like that instead. If you do a merge, which is just like a database join, then again, this is going to be significantly faster. Again, it's also, the process is also batched as well. So it kind of runs once up front and then you're not having to worry about these kind of calculation issues. So we've had Dinesh join. So, hey Dinesh, thanks for joining. Thanks for saying hi and stuff as well. If you could let us know where you're from, kind of what tools you're using, that'd be awesome as well. Okay. All right, and also just for anybody else here as well, if you're following the stream right now, if you could say hi, that would be awesome. Just let us know what you're using. And I don't know if this kind of this particular topic is people finding this helpful or not. Another R and Excel user, awesome, good to see. Okay. All right, so let's talk about parallel processing. Now, parallel processing, basically means that you're using more CPUs and more cores on the CPU to be able to do different things. So instead of just having, using, you can process lots of things at the same time. Now, here's the thing. Excel and R are not, R is not natively multi-threaded, which means it doesn't take advantage of parallel processing by default, actually, right? Now, there are a number of libraries that enable parallel processing. Another easy way to get parallel processing in R is to use the Microsoft version of R instead of the CRAN version of R. So now the Microsoft version of R is also free. So you can download it you can Google Microsoft R, or it's the site is Imran or something like that. But Microsoft R does parallel processing. So something to kind of keep in mind in there for certain types of calculations. And now here's the other thing: not every type of calculation even benefits from parallel processing, because there is a certain overhead that's required to parallel processing. Because effectively, what you need to do is you need to take your data, split it up into multiple different threads, send it to the processor, and then kind of rejoin it back together in a way that actually makes sense. Now, if you have a lot of data, and then that may make sense to do, but it doesn't always. So just something to kind of keep in mind there. Now, while I'm talking about Microsoft R, just the other benefits of Microsoft R is that besides parallel processing, multi-threading, that's a thing, Microsoft R takes snapshots of all the libraries. So, one of the things that you probably heard me talk about before is that R has over 10,000 libraries. And these all get updated at different times. And sometimes the compatibility of the libraries go out of sync for a little while because there's lots of different people who maintain these things. Now, again, if you're using R just for yourself, this is... it sort of doesn't really matter quite as much. But when you start working with teams and you want your code to be able to run everywhere, then you kind of want to make sure that everybody's running the same versions of the libraries to make sure that everything works. And that's another thing that the Microsoft R can help with, because they take snapshots of all the libraries, right? So there you go, a little bonus bit there. So Dinesh, I see you're interested in Power Query. That's awesome. So Power Query, I think that's typically the reason why I like to teach Power Query actually is, and why I think that, like, even if you use R, I think that Power Query is still kind of useful to know, because effectively, Power Query is how I get data into Excel, right? At any time. And most people just think of Excel, data as a file that you open up in Excel, and they just double click on the file, it opens up, and you start manipulating the actual file. Now, if you used R for a while, now I guess even in R you may or may not be doing this, but one of the key goals is to be able to produce reproducible work, right? Which means you're going from source data to end result, and you want to be able to have every single one of those steps recorded. And if you manipulate the source data, then you can't recreate your process again because you don't have the source data anymore, right? So now this is the kind of really, really key and important part. Now, if you know R, then you can kind of automatically do this already, because that's kind of what you're doing all the time. But so long as you don't necessarily do that in R, but that's kind of what you should be doing. If you're using R, ideally you really want to be able to have all your steps from the original clean source, untouched source data. Now, I think this should also be the goal, even if you're using Excel as well. And this is what traditional Excel doesn't really allow for, because as soon as you open a file, you start manipulating the actual file. And then you have to go say, if you accidentally hit save, you've just corrupted your source data, right? Now here's another little tip as well that not a lot of people are actually kind of familiar with this, but the fact that if you a lot of people like download, say, Excel files from maybe a server or internet or whatever it is, and they open it in Excel, and then they hit save as to save down their file somewhere. Now, what a lot of people don't realize is that just the very fact of opening a file in Excel, even if you haven't touched anything in it at all, actually is able to corrupt that file, particularly with things like dates and leading zeros. So for instance, if you have an ID column and it has a bunch of leading zeros, just opening the file in Excel will drop the leading zeros and convert that from a text into a number, which means you've corrupted your IDs if you have numeric IDs. So really, really important there. Do not click the Save As button in Excel. Otherwise, you don't have source data anymore. With dates as well, this is another really, really big issue with the dates in Excel. With the dates, if you're not in the US and you download US date data and open it up at Excel, it'll corrupt the dates because the month and day are kind of inverted. Now that doesn't automatically get corrected in Excel. It just becomes corrupted data, right? So that's really important to basically not do that, right? Now, okay, so this is one of the things where Power Query comes in really handy. So I got a question here as well: how to automate tasks in R like we do in VBA. So that's a really good question. Now, I can answer this in a couple of bits actually. So first of all, if you're looking to move away from VBA, and what are the things that kind of people typically use VBA for? Well, first of all, people use VBA to do one thing is data prep, right? Now, if you use Power Query, right, you don't need to use VBA at all. In fact, it's much, much cleaner, much more robust. Because what is the problem with VBA exactly anyway? If you say record macros, or even if you don't record macros, the thing is that the VBA doesn't actually refer to the data. It refers to elements of the spreadsheet. So what you're referring to is cells and ranges. So let's say you have a table of data. One really typical thing is you want to be able to just do something with a column. VBA doesn't really allow you to easily do that in a clean, concise way, right? Because either if you record macros, it's even worse, because you typically end up with some sort of fixed cell range. Say you record something and it goes from rows 1 to 10, and next time your data has 11 records, then you're kind of screwed. You can use kind of little tricks like Excel end and different things like that, which will jump to the end of the range, but that's really not very robust either, because effectively, if you have gaps in your data, then it will stop at the gap and not at the end of your data set. And there's other hacks for that as well, by starting from the end of the sheet. But if you're missing a bunch of data in your last record or something like that, then this thing also breaks, right? So there's so many things that make VBA break that I really, really wouldn't recommend it for data cleanup. Now, the nice thing about, say, something like R is that you just to refer to a column, that's kind of something which is natively there, right? So you just type the column name and say, do this to this column, right? And so you can manipulate even like half a dozen columns or something like that. And, you can often do that in a single line of code. You're not looking for the end of the range, and you're not worried about if the columns moved like you are with VBA and all this sort of thing. So, that just works much, much kind of cleaner. Now, if you're not at kind of the level of coding, then that's where Power Query again comes in really, really handy, right? So Power Query does all these data manipulation things for you, but you don't need to do any code at all, right? So actually, I have a screenshot of Power Query up here. So here you can see that, well, you've got all these transform functions in Power Query, right? So you've got use the first row as header. You've got transpose functions. You've got splitting columns. You've got formatting column. There's a whole ton of really useful and cool transformations that you can do with Power Query. So these are the kind of things that you should be removing from your Excel process, because basically all the Excel processes are either manual or you've used VBA to automate them and they're not robust, right? So Power Query does this much better. And you can't see it, this extra little panel over here, but every single thing that you do here, it records it just like you would record a macro. Except the process is much cleaner, because if you're removing this column, it actually has the name of the column and it says, remove column or something like that, to that effect. As opposed to VBA, which is maybe it's remove column B or something like that. And that can change, right? And because it can change, it's not robust, right? Okay. But again, really good questions, something we can probably cover off in a bit more detail some other time. I mean, I do have, if you check out my channel, I have a ton of videos actually teaching Power Query and R and stuff as well. So, do feel free to check those out. Okay. And now let's go into structures. Now, here's the thing that, this is a topic I find kind of really interesting as well. So again, as mentioned, if you're talking about computer science, then you'd be talking about things like arrays and lists and everything, which is kind of useful as well. But, I'm going to be talking about structures from data structures from the point of an analyst. So here we have an Excel table, right? So you can see that you've got rows and columns. And this is, like your typical Excel formula where you can multiply a couple of cells together. Now, one of the things that one of the good things and the bad things about Excel is that it's very flexible, right? Like you can stick anything anywhere you want. So if we go back to the piece earlier where we were talking about data types and memory management, this is kind of like allocating the maximum drawer size for every single cell, right? Now, obviously, if you're looking at rows and columns, this ends up being really a lot of space kind of allocated. And this is why the kind of spreadsheet model is kind of not really so efficient for working with data. Because usually we're pulling data out of something like a database, or we're pulling it out of a system. And when we're pulling stuff out of a database or system, you have structured columns. So over here we have, columns which are named, right? And columns which are named, and they have a single data type, right? Now, again, this is why it's so much more efficient and effective to use Excel with Power Query than it is to use the regular spreadsheet model. Now, here's kind of, there is still a little bit of an issue where when you take the data from Power Query and you drop it when you actually import it and load it into your spreadsheet, it becomes this kind of unstructured kind of data again. Now it looks a lot more structured, and it is using something called a table, which is I should have taken a screenshot of this, but anyway, it's the kind of the colorful table with the kind of banded rows, and you've got auto filters already applied to it and everything like that. That's not exactly, it's not completely a regular sheet, because you can actually refer to table names and column names, which is really, really, really useful as an analyst. But it's still not as strict as, a data frame in R or a table in a database, because you can kind of still you can override it and you can put in any type of data that you want, right? So even if you have a numeric column, you can start typing text in there, right? And this is part of the problem with Excel, because if you're an analyst, you're going to be fairly strict about these kind of things. But Excel does not enforce that strictness for you, which means that if you give this spreadsheet to other people, it's very, very easy for them to kind of mess it up. And I know you've got things like data validation and different things like that, but again, those are very, very easy to override and break. So that is kind of part of the problem, right? So now that's your typical spreadsheet model up the top here. Now on the left here, I have got this. So this is row store versus column store. Now, what are we actually kind of looking at and talking about here? Now, your typical database is actually a row store database, or a relational database. So Microsoft Access, SQL Server, Oracle, MySQL, different things like that. They're all row store relational databases. Now, here's the thing. Relational databases were built for, they were built for transactions, and secondly, they were built to optimize storage. Now, these databases have been around for decades now, so they've been around for like a really, really, really long time. And they're still the most common type of database. In fact, a lot of people don't even really know that some of the other types of databases exist, but they're still one of the most common types. But they're actually the slowest for a lot of different types of things. Now, I don't want to, say that, relational databases are terrible or anything like that. Again, these are just different engineering types of problems, and different tools are going to be optimized to solve different types of problems, right? So like I said, a relational database is very good for minimizing the amount of storage you need. Now, that's a much less of an issue these days, because, there's so much more storage than there used to be, right? Typically, relational data, like record-based data, doesn't take up that much space. What does take up a lot of space? Well, things like photos and videos, and photos and videos are the vast majority of big data, right? It's not actually relational table-based data at all, right? So just something to kind of keep in mind there. So the thing is, though, that from an analyst perspective, we're not usually looking at individual rows. What we're usually doing is we're trying to aggregate this data, right? So you don't want to have to retrieve like this row, this row, this row, this row, this row, and then do something across all of the rows. What you really want to do is like take a data set. And this is where over here I've got a column store. And you can see it's basically the same data, right? I mean, all of these could be the same data. So this is a table, this is a table, this is a table, right? They're all tables. But this one's organized into columns, right? And when the thing is organized into columns, it becomes much, much more efficient for aggregating that data, right? So, which is usually one of the things that you want to do, right? So you can actually compress this by a column, and that actually make things faster as well. Like compression actually is the principle of compression is that you're representing a larger amount of data with a smaller set of data. So compression can actually encoding is like compression, and encoding can actually enable your computer to process much more data much faster as well, right? Now, inside of R, this is kind of effectively the default kind of structure. The data frame or the tibble is effectively this column store or column-based organized data, which makes it very fast, very quick to work with. Now, in Excel, it actually has a feature called Power Pivot. Now, I don't know if anybody here has actually heard of Power Pivot, but it's actually an in-memory column store database, right? So it actually works really fast, and it actually enables you to work with fairly large data sets. Now, this is different from Power Query, and it's different from the spreadsheet model. And this is one of the things about Excel, right? Excel was originally a spreadsheet, but now it's actually much more than a spreadsheet. But most people don't even know. About it, right? So if Power Query is your kind of transformation kind of tool, your spreadsheet is kind of like a general kind of flexy kind of calculator. Power Pivot is kind of actually what you would ideally want to do your analysis in. The problem with Power Pivot? Power Pivot's what you want to do your analysis in. The problem with Power Pivot is that it used to be a free add-in for Excel 2010 and Excel 2013. So anybody could get a copy of it and install it and start using it. Now, unfortunately, as of Excel 2016, Microsoft actually removed the add-in, right? Now they built it into some versions of Excel, right? So if you're lucky enough to have some pro business version of Excel, then you can use Power Pivot. But I think it's just such a shame that it's like if you have any other version of Excel, you can't even install the add-in anymore, right? It's not available, and I think that's kind of really, really disappointing, which is why I don't actually really teach Power Pivot anymore. Partially because I don't have that particular copy of Excel installed on this computer that I'm using right now, and I think a lot of people, if you're just trying to learn from home or something like that, won't have the right version of Excel to be able to use Power Pivot either, right? So that's why I mostly focus on Power Query, right? You're still going to get a lot of the benefits, right? And when you start getting into bigger kind of data sets, so Bart, so you use Power Pivot too. What version of Excel are you using? So, yeah, again, Power Pivot can be really useful, right? So if you work in an organization, then maybe it's kind of available. But I think it's just such a shame that it's not available anymore, because it just makes your work a lot less portable and everything as well. But anyway, there you go. You can get a lot of benefit out of just using Power Query, because you can do all the data transformations, all the joins and kind of stuff like that. So again, people would typically use databases for joins. So, if you're still using, like SQL Server or Access or something like that to kind of mash your data together, because you think you have a lot of data that you need to merge, then you kind of don't really need to. You could do that in Power Pivot, in the Power Pivot data model, or you could just kind of pre-do it in Power Query. So you can kind of just do that up front. The only problem is that if you're only using Power Query without using Power Pivot, then you are definitely limiting the amount of data that you can actually process in Excel, because Power Pivot can process hundreds, if not thousands of times more data than just kind of basic Excel. Right. Okay, so these are kind of the three kind of table based data structures, right? Now there's a couple other data structures that I think are interesting as well. So we got people using Excel 2016. So if you're lucky enough to have Power Pivot with Excel 2016, it means you've got like some pro business version. So maybe within companies that's a little more common as well, right? But just something to think about there. Okay. So the next two types of data structures are quite interesting, because one of the things when we start working with data, a lot of times we get into the mindset of tables, right? So you work with Excel or database, you're thinking tables, 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 tables. Now there are other data structures as well, which for certain types of problems can be much, much, much more efficient. Now you may have heard me talking about things like graph network databases and stuff before. So I've got a few videos on those as well, so you can check those out. Now I haven't really talked about document databases too much. Now, over here we have this is a JSON file, and you can see that we have this data format, which is this sort of hierarchy, right? So this is the kind of data format that you get out of a document database. The most common one is probably MongoDB. And the reason why this is handy is that because we are comparing back again to relational databases like Microsoft Access or SQL Server, you normally have tables, you normally have data spread across multiple tables, right? So for instance, here we have product and product details, and we have sales, right? So you might have a product table, you might have a product details table, you might have a customer table, you might have a sales table, and you have like all of these different tables, right? Now, once your database starts to grow in size, and once you're starting to look at, once your database starts serving lots of people in multiple locations, then it starts to actually become really, really inefficient, because every time you need to do a join, you need to join the entire table, and you need to do this on very large data sets across multiple regions. It starts to become really, really slow. So what the document database does is it says that, okay, well, instead of spreading my data across lots of different tables, which it kind of has the benefit of sort of organizing the data, but it also has the benefit of normalization is the process of like splitting it out into all these different tables. It has the effect of making the data smaller, right? Because you get rid of duplicates. But as mentioned, storage is not as big as a deal as it used to be, right? So if you create an object, right, and you encapsulate all of the details of that record in like a kind of single record, a little bit like denormalizing a table, if you kind of know what that means, then it's going to be much faster to write and retrieve those records, right? Also, if you're not looking into aggregation, right, then, and you just need to store and retrieve individual records, this is particularly useful for like sales and customer records and different things like that, where a customer wants to look up their details. Maybe you don't want to grab your data from, maybe you don't want to have to join like 10 different tables just to retrieve a single customer record, because that's a lot of overhead and that's really slow. Then you could create a document database which has all of that customer detail encapsulated in a single object, and that object can be located in a server which is close to that customer, which means that any reading or writing of that data is very fast, right? So that's kind of the idea of a document database. So that's another thing which is quite common these days. Now, it's a little bit strange because, it's not strictly a table, it's kind of more like a hierarchy. And this can be a little bit like if you're used to like object-oriented programming, like if you use Python or Java or something like that, then perhaps this can be a little bit easier to work with those kind of languages, because they already kind of deal with these concepts of objects instead of just tables, right? But anyway, that's what that is there. And then a graph database is effectively a connected document database, right? So a graph database, it has all these nodes, and each node is like one of these objects, and it also has these links, and these links between them, these lines between them, are known as edges. And these edges can contain a whole bunch of information themselves as well. So it's a little bit like a join in a relational database, but a join can't have any information in it. A join exists. A join is actually inferred by the primary and foreign key, right? So that's effectively your IDs, your lookup columns in relational databases. Whereas the edges in a graph network, they contain the information about node, the parent and child nodes, or the node A and node B. It can have attributes to that relationship. So you could have, say, I don't know, like a friend relationship, right? And then that friend relationship could have a score to say how much of friends are we exactly, and all that sort of thing. You can have relationships which have certain types of properties and stuff as well, right? And by recording all this information, it can make answering certain types of questions much, much more effective, right? Because if you're looking at relational databases, especially things like if you have to do recursions, if you have to join across multiple tables and lots of tables, then to answer questions, then that's actually really, really slow, right? Whereas with a graph network, that is actually very, very fast. So they're used for all kinds of things, like shortest path calculations, like organizational hierarchies, and recommendation engines, right? Like Google's PageRank algorithm kind of works on a sort of graph network algorithm, right? So it can be a very, very powerful analysis tool to add to your toolkit, right? Okay. So let's just have, okay. So I just got one quick question here. How can I extract data from R with the help of Power Query? Now, there's probably a whole bunch of different ways. Generally, what I would do is I just write underscore CSV from R, and then I'll use the get data function in Excel, which loads a Power Query to load the data in. And again, like, because I do all of my data transformations in R instead of Excel, I personally don't use a lot of transformation features. I don't use a lot of the transformation features myself, but I still always load the data in via Power Query because it links it, right? And this is a big deal, right? Because like I said, every single thing that you want to do, you want to be able to link back to that original data. And again, if you're doing reporting or something like that and you're swapping out the data like every single month, you don't want to, even if you do something as simple as a pivot table, right? You don't want to have to copy and paste a new data set in and make sure it's the same size, or, like if it's too small, then you have to shrink your range. If it's too big, you have to stretch your range, all these kind of things. And, there's various hacks for that, but still, it's not very clean, right? So you don't want to have to redo that stuff every single month or week or however often that you want to kind of update and refresh your data. By linking it to Power Query, again, like if you go through some of the free courses and stuff like that I have on YouTube, then you can kind of see that even if you do nothing to your data in Excel besides, do a report off it using some pivots and pivot tables, which is generally what I recommend, right? Generally speaking, I try and avoid formulas as much as possible in Excel. Right. And again, this is coming back to all the stuff that we talked about through this whole stream here. Whenever you use a formula and you need to fill that formula, it makes lots of copies of it. And because it makes lots of copies of it, it becomes really slow. Now, I typically work with like fairly large data sets. So, I definitely don't want to have lots and lots and lots of formulas. The other thing is this, it's just hard to maintain because you'll set everything up just right. And someone like Excel, because it's not strict, anybody can come along and just override your formula. This stuff happens, right? Someone will take your spreadsheet and they will overtype your formula with some hard-coded value or something like that, right? And these kind of things are just a bit of a pain, really. And you really don't want to have to deal with that kind of stuff, right? Now, if you use the kind of process that I kind of discuss throughout some of my lectures, then basically you load the data in via Power Query. It ends up in a table. You run a pivot of it, and you do your pivots of it, and then you do your charts off of it. You can set things like to automatically resize the widths of columns and different things like that. So you can set a bunch of layout options so that you can get your formatting fairly fixed. And then you just hit the refresh button. Super easy, right? So you just hit the refresh button, the entire thing refreshes, and you don't touch a thing, right? So this is what people kind of use VBA for, except you don't need to use VBA at all. You can completely cut out VBA and still 100% automate your entire process. You just have to make sure that you don't introduce any manual steps within your process, like any kind of copying, pasting, and this and that kind of stuff like that. Really, that should all be done in Power Query, if not done earlier in R, right? Then, you just hit refresh and you're good to go. So that's hopefully that answers that question there. So just coming back to this slide here, we've talked about quite a few things now. We've talked about memory management and how, this is why things like C and Java are really fast, because, they're very detailed in terms of things like data types and memory management. But typically you wouldn't really want to use them because they're a lot of work. They're really, really hard to use. So then you've got things like Excel and R. Often in R, you don't need to really specify the data types, but as soon as you import it, it's going to infer a data type, and then that data type is stuck there. And you can change it if you need to, and you can change it in import, you can change it after the data is imported. And then that's still going to be much more efficient for all the processing, all the analysis you do after the data is loaded. Now, this is why, again, this is kind of much faster than Excel spreadsheets, the spreadsheet part of Excel, because the spreadsheets don't enforce data types anywhere. They don't enforce columns, they don't enforce data types. That's why it's really slow. That's the other reason why I really like Power Query in Excel, because at least you have data types and you have columns, so everything gets imported clean, right? It can still get messed up when it hits the spreadsheet model, which is why if you have it, Power Pivot can be better for that. But again, I find it hard to recommend Power Pivot just because it's not so available anymore, which is really disappointing. The other benefit of Power Query is it works for Excel as well as Power BI, right? So it's the same thing in both Excel and Power BI. Now, again, Power BI, it has this kind of in-memory column store kind of model. So effectively, I don't know if it's exactly Power Pivot, but it effectively has the same engine behind it anyway. So you're going to get this kind of speed and flexibility out of the box. The other benefit as well is that Power BI, Power Pivot, or the power things, right? That's Power Pivot. It's very useful for being able to do joins between tables, just like you would in a database, right? Except it's all in memory. But it's not always the easiest to work with because, you've got DAX, but DAX doesn't really have as many functions and formulas as, say, R. It doesn't have as many data structures and data types and everything like that you can get your data out to, right? So R, you've got your data frames, which are like column stored tables, but they also have, objects like document objects, and you also have graph networks. And you can also automatically output everything to data visualizations and stuff as well, which you can't really do with DAX, right? So what you need to do, if you're using Power Pivot with Excel, you need to get your data back into the sheet before you can put some Excel chart on it, right? And that's just really not such an efficient process because one, you're massively truncating the data. so you're not getting as many dimensions of data points and everything like that. And the spreadsheet part of Excel, I mean, this is kind of funny to say because Excel is predominantly a spreadsheet, but the spreadsheet part of Excel is actually really the bottleneck of Excel, right? But it's what most people are familiar with. So, so the charting is definitely a lot harder in Excel than it is going to be in something like R or Power BI. So Power BI is like Tableau effectively, right? So you can just click a few buttons and you're going to get your data visualizations out without having to write anything at all. So it's actually much better. It's much faster. It's like you could do charts directly off Power Pivot, right? Which you can't do with Excel. So that works. That works really well. Now, here's the thing with Power BI. It is free to download a desktop copy and just kind of do stuff for yourself. For as a data exploration tool, it's really handy, right? So especially if you're not 100% up to speed with some of the the new sort of visualization techniques, and if you're not up to speed with sort of visualizations in R, then that can be really, really handy, right? To use it in Power BI. Now, the fact that you can download a copy for free is fantastic. I mean, Tableau costs $1,000 to $2,000 or so. So Tableau is much more expensive, right? So you can download Power BI for free. But where do they make the money? They make the money with the sharing. So as soon as you start sharing your data, which is typically what you want to do, then they're going to start charging for that, right? And this is how they make the money. And this is why, Power BI is a great solution, but unless your organization or company is kind of willing to fork out and spend the money for Power BI, then it's a bit hard to share your work, right? This is where I really like R as well, actually. So, a lot of people will use Excel as the distribution mechanism for their data, right? Why? Because everybody's got Excel installed, right? So that's kind of a solution, but actually it's not my preferred solution, right? So actually it's probably worth mentioning this as well, because I had the question of how do you get R data into Excel? Why would you want to do that? And it's like predominantly the reason why you want to use it, get R data into Excel, is so that you can take all your findings and all your analysis that you've done in R and basically report off of it. Now, to be frank, if you can actually report directly out of R, then I think that's, in a lot of circumstances, that can actually provide an even better solution, right? Because you're generating reports directly. You've got programmatic control, so you can, now this is the other reason why people want to use VBA, so you can do loops. So instead of generating just one report, you can generate 1,000, which would take a really long time to do manually. You could just do that in R, like really pretty efficiently. What is the output format? Well, you can output as a Word document, you can output as a PDF file. My most preferred method is outputting as an HTML file, right? Now, these are not just static HTML files either. You can actually have dynamic controls and everything like that in these HTML files. And what's the great thing about an HTML file? It's like, well, anybody with a web browser can use it, which is basically everybody, which means it's even more distributable than Excel, right? Because here's the thing with Excel. Not everybody always has Excel. They don't always have the same version of Excel. They don't always have the same plugins, the same add-ins. They don't always have, if you do introduce VBA, they don't always have macros enabled, right? So, there are actually kind of limitations, whereas HTML is actually a much more distributable format, right? Now, the one challenge is that, okay, it's like, well, but people still want it in the table. They want to be able to manipulate the data and all this sort of thing. Now, here's the thing. With Excel, if you've got these kind of big sheets that you send out and everything, you've got all your data in these sheets, and they can, like I said, they can start to change and kind of manipulate these things. And, it can be very hard to keep track of versions of those. And this is another thing where data starts to get really messy and kind of corrupted and everything like that. Now, in in our sort of web-based dashboard, which you can just email to people if you want as well, or host it on a web server, even better solution. If you can, then you can add an export button to your dashboard that enables an Excel download, right? So you can send them an HTML dashboard, and they can still extract the data that you allow them to into Excel if they want to be able to do certain manipulations, right? But then, when you get back the data, then it's not, you're not worried about, which version of the Excel spreadsheet am I on? So, and again, this is, probably have a whole nother sort of section on different tools for collecting data, because Excel is, it's not actually the best tool for collecting data either, right? So there's a whole bunch of different options, right? So it's probably worth to go over those a bit more detail another time. But anyways, so that is I think we'll call it wraps for the day. If you want to find out any more about any of the stuff I am doing, you can find out more about me at www.datastrategywithjonathan.com. If you found this video useful, please give a thumbs up. And if you're not subscribed yet, please subscribe to the channel. And I will see you next time.